Please join me for the meditation. And Jacob, since you haven't joined us yet, can you text Robert, please? Can you hear me now? Oh gosh. Did you
Yes,
hear anything I said? Nobody heard
couldn't hear you
anything?
before. No.
Oh no. I'm getting a weird echo. I don't know why. I might have to skip a mic. How about, can you hear me now?
Yes, no echo.
No echo, but maybe not the best quality sound. So, as I was saying while everybody was meditating, bringing the attention to the third eye. Oh gosh, were you guys doing any of these things? Or you didn't hear anything I said? Okay. So when we're meditating, we're I was saying, bring your attention to your third eye or your heart chakra while you're meditating. This just bringing your awareness there develops the energetic vortex and brings you into a state of mind. And it's helpful for mathematics. It's also helpful for becoming more conscious, for progressing along the path to enlightenment. If we are energetically healthy, if we can feel our chakras, it really empowers us. And each of the chakras has a different quality of awareness with it. So the third eye and the heart work really well together for mathematics. The heart is the knower through feeling, and the third eye is the faculty of understanding. And the third eye, we understand and develop a sense of clarity. The heart has a different quality of feeling, a more ineffable knowledge. So if we, a few things I was saying is you can do figure eights on your third eye. This develops the energy in the third eye. You can also pull the finger out, and the suction or the expansion creates a decrease in the concentration of energy that actually suctions the energy out of the forehead. So Karan, you should try this because I know that you have studied a different path, but I highly recommend you explore chakra meditation. Chakra meditation very quickly puts you into a different state of mind and makes it more possible for you to do a variety of things. You can do mathematics better. You can feel and be more intuitive. You can, different chakras like the navel center gives you more power to will your energy or will a situation into a certain state, condition, circumstance. So we can do that when we begin our meditations. And I was joking because I said meditations, but this meditation is a mathematical meditation, right? And once we're doing the mathematics, we can, if we get an urge or a feeling of energy, we can step out into the energy again, because doing the mathematics cultivates that energy as well. So we can step into the energy again. Like you can get really high while you're doing mathematics, and that's part of the goal as when we do mathematics as a spiritual path. We want to get so clear and so orderly that this power surges through us and we surrender into the unknown. So there's many nuances to that, but I'm just throwing some of this out there for now. Perhaps that makes sense to you, perhaps it doesn't. Start contemplating these things, start experimenting with them. Can you feel the chakras? And it's not a matter of believing in the chakras. People on Instagram have given me a hard time before and said that their chakras don't exist. Well, I can tell you without a doubt that I feel my chakras, and that's the degree of existence that I'm referring to. That's like saying sensation in your finger, in your pointer finger doesn't exist. That's ridiculous, right? Like it exists as a part of your experience. And I would say they probably exist in a detectable way as well if we had the right tools for detection, right? So the ability to prove things is dependent on the tools that we have and use to detect those things. So you might say electricity doesn't exist. Well, until you develop the right tool, you may not be able to prove that. Nice. Thank you, Soleil. Yeah, so really, for the most part, it's not even about proving this. I'm offering a kind of protection against people who don't believe in them and try to detract from it. That's all, right? What proving it is, it could be your dharma. It could be a fun project. It could be useful in application technology, various things like that. But in terms of the spiritual path, feeling them, activating them is paramount, right? So, and it's a long journey. It's like building a muscle. You can also perhaps just feel it right away, but a lot of times, even if you do, you can expand that feeling and strengthen your chakras over decades. So, all right. So mathematics as a spiritual path means that we get to experience order in the mind. And we also get to focus on something that is eternal. And if we have a particular predilection for mathematics, if we enjoy the subject, we get to be childlike and play and enjoy discovering these wildflowers in dimensionality. They exist inside possibility. And so that's what we'll do today. So I want to text Robert. Robert's here every time. And just double check what's going on with him. Jacob, did you text him?
I can.
Okay. Or call him. Oh. All right. You guys want to keep meditating or shall we start doing some mathematics?
I'm fine with starting.
Okay. So we can do a number of subjects today. The thing we have scheduled is binary counting, which is quite fun. One of the reasons why we might explore counting in different bases or doing mathematics in different bases is it forces us to not fall back on memorization. So if I said, what's 11 times 11, like we did last week, Carlos, you saw that, right? So you can see 11 times 11, you may fall back on memorization and say, oh, it's 121. But where there's memorization, we're not bringing vitality. We're not actually doing math. We're just remembering it. So this for fun. Anybody know what 21 times 21 is? 21 squared. Just through visualization and no rush. Please don't blurt out. See if you can get it and then. Do you see it, Carlos? You're able to see it still?
I think it's 481.
Oh, so close. So how many are on the top and the side?
There's 40.
40 total, right? 20 on
Yeah.
top, 20 on the side.
Oh, 20. Oh, okay. Yeah,
Right?
so it'd be 441, right?
Exactly. So now I know, Scott, you weren't here for that, but just as a demonstration, Carlos, you just went through the actual activity of doing math. So this is very central to the theory here. The pedagogy is what makes it spiritual is you just did math. You didn't fall back on memorization. Memorization is actually very much not spiritual because we're not perceiving what is. In spirituality, we want to clear ourselves of conditioning and see what is with beginner's mind, Zen concept, beginner's mind. When we see what is with beginner's mind, we meet what is with a full vitality and a full life force. And what you just did was you actually did the multiplication. So just to think about it, he just did 21 squared in his head visually, and he's identified with not being supernatural at doing things like that, and here he is doing it, right? So you're developing new faculties around mathematics to perceive them and do them directly. So when I say the direct perception of abstract truth, that's that. We're directly perceiving it as an active present of doing it again for the first time every time. So when we change bases, if I were to now say, what if we were in base 19? So, or, okay, let's do base, fine, we'll do base 19. So base 19 instead of base 10. So the reason it was base 10 is I don't want to lose Scott though. Right, you got to be here every week if you can, but I know you weren't able to be. I could show this animation again, I guess. Well, let's do something. Let's do something new. But my point, Carlos, is if we changed it to base 19, you could visualize groups of instead of 10 in groups of 19, and you would come to the conclusion that the number is, anybody know? Then we'll move on to the new stuff after this. So 21 squared, and then in base 19. So it would be 1 19 19, 2 19s, and 1. So 1 19 19, 4 19s, and 4. It looks like 12 squared.
Could you explain quickly?
Yeah,
I lost that. Could you explain quickly? Like, is that the
I'm
one
going to do a quick explanation because I think you'll get a kick out of this. So you got to do it really quickly. Although I wanted to, I don't have my coding demonstration up, so I'll just use this. So if we were to look at 21 times 21, we could see perhaps a 10 and 10 by a 10 and 10 gives us 100 little squares in this section, 100 little squares in this section, 100 little squares in this section, and in this section as well. So we can directly perceive that 10 plus 10 by 10 plus 10 is 400. So we're saying 20 times 20 can be visually experience this multiplication as area. It's like 10 by 10 4 times. So let's just make sure, Scott, does that make sense? Or I mean, this would,
Yeah.
We spent a whole hour on this, so if you get this very quickly, that'll be very impressive.
I understand. I understand the concept. I like the idea of visualizing it. Yeah.
Okay, wonderful. So then this is the little jump. We said, okay, what if we add a layer here? So now it's not 20 by 20, it's actually 21 by 21.
Yeah.
So how much did we add? We added
21.
We added 10 and 10, almost, and then 10 and 10. So we added 41.
41.
Yeah. So this is what Carlos was seeing. And then if we were to do this again and say, well, what if this was 19 by 19? And this was actually 2 more layers. We would have 1 19 19, which is like 100 in base 19. And then we have 2 19s here and 2 19s here. So we would have like, it would be like 4 19s. So this is a funny thing about different bases. This usually means 40, but in base 19, it would be 4 19s. This usually means 10 by 10, like 10 fingers by 10 fingers. But in base 19, it would be 19 by 19. And we would represent it just with a 1 0 0. Each 0 means times 19 more.
Can you say that one more, sorry, one more time? I'm just lost. If you could just repeat it so I can,
For sure. So
slower.
in our base system, 1 means 1, pretty straightforward. But as soon as we add a 0, we mean one set of something. But what is that something now? That something is defined by the particular base system we're in. So if we're in base 10, it means one set of 10, because what comes after 9? We usually say a 1 and then a 0. It means one group of 10 now, the number after 9. But in a different base, say base 16, what would come after 15 would be a single digit number, and the next number would be 116. So I know maybe this is a lot very quickly, but we kind of jumped into it. Let's Robert, can we talk about it? You understand? So we're trying to just, ironically, we're doing something very, very basic, and that is actually 10 ends up being a pun here. But what we're doing that's basic is that we're just realizing what our base system is. If you count to 10, you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the next number is a 1 and a 0, which means a single, a unit, and a set, one set. This would mean one set, one set of sets, right? So if you were a kid playing with blocks, you'd say, look, I have 10 blocks. And then you'd say, look, I have 10 blocks of 10 blocks, 10 boxes of 10 blocks. And then if you put another 0, you have 10 cartons of 10 boxes of 10
Why
blocks.
don't you try doing that now with your own design?
Right, so this is basic. So if I were to say 1, 2, what I'm saying is one set and 2 more. It's actually quite simple, but I'm not saying anything fancy here. I'm just talking about what is our number system. Ayush, what do you think? You have a good microphone today, you know.
Yeah, I'm trying to understand like set and the base system. Like 12 is like, is it like 10 plus 2? So one set plus 2 more. I'm trying to understand too.
Yeah, so I'm simply, I mean, I think, I wonder, perhaps you haven't given this much thought, but I'm talking about the same numbers you learned in elementary school. We're just saying, what do those numbers mean? So if I say 43, I mean 4 of something, right? 4, it means 4, right? There's a 4 there. Why is there a 4 there, right? You're like, this is not 4. This number does not represent 4, but there's a 4 in it. So I'm not saying it, I'm not trying to be tricky or anything here. I'm saying exactly what it is. That 4 represents 4 tens. It means 4 tens and 3. See, but we get so used to these things, they become inadvertent assumptions. We have to change that. You have to become aware of everything. This is a very spiritual thing to do, is to be aware of all the assumptions you're making. Not make any assumptions, make them consciously. So Robert, 4, 3. Doesn't that mean 7? If we were talking to an alien, right? They'd be like, isn't that 7? You say, no, it's not 7. The 4 means 4 tens. And they go, what do you mean? Why tens? Why 4 tens? Why not 4 12s? We have 12 fingers, the aliens say. Right? They're like, doesn't that mean this number? And you count it up and it says 39. Well, why is that? Why did they show me 39 when I wrote this? Oh, sorry, 51. Right? Well, 51 is 4 12s and 3. 5 10s and 1 is 4 12s and 3. Soleil, what do you think? I know Soleil really puts his focus in, so I know he's onto something.
I mean, it sounds like it's a visual way of doing math in the head, and that's how I do my math. I'm not the greatest at math though, but this concept is pretty simple so far.
Okay, so this isn't particularly visual. This part, I'm emphasizing the language of mathematics and elucidating the assumptions we make within that language.
Yeah, it's really nice to think about it the way you, in a way of being aware that we assume when we look at numbers, we just assume it is as it is, but it really means a whole set of things here. Like looking at 43 in my head, I'm seeing, 4 boxes of 10 plus 3 in my
Right.
head.
Also, why isn't it 3 boxes of 10 and plus 4?
Because we read left to right, which is an assumption.
And there you go. Somebody's getting it. Thank you. It's an assumption. I would call it. So here's a key word for anybody in the mentorship program. It's human artifact. Human artifact. It's created by humanity. Yeah, please write this down and remember it, because this is key stuff. Human artifact means that it's not, we want to distill mathematics of human artifact by becoming aware of the ways that we've applied human artifact. So I'm saying mathematics is not a language. Mathematics is abstract structure. We can describe it with words and symbols, like here, but those symbols are pointing to something that is abstract and without description. So why 4 3s represents 4 10s and 3 1s, not 3 10s and 4 1s? Well, that is because we decided to do it left to right. And we could have wrote 43 like this. If we were like aliens, right? We'd be like, okay, look, it's 43. Why does that represent 43? Well, the number on the right tells us how many sets, and the number on the left tells us how many units, right? You see how I'm just created something brand new, but I'm challenging myself. Now, if you did this in school, you'd probably fail your classes because you wouldn't just be answering the questions and doing the tests right away, right? We're slowing down to challenge ourselves to actually elucidate all the different dimensions of mathematics, all the way down to counting. And if you do this, you awaken genius, because it's the places where you don't understand completely, don't have complete comprehension, that prevent you from flying in math. You have to have an integrity of comprehension. Think of it as like a planet, which has a strong core. That's all the mass has been filled in. There's a couple little caves down there, but very many, almost nothing. And it's just filled in, right? A core of comprehension. Carlos, what do you think?
Yeah, kind of a lot to take in a sense, because then it's just challenging every single thing that I've come to understand in a sense. Because then why is it in bases of 10? Because we have 10 fingers, so like why
Exactly.
is it based on our fingers that we have this entire thing, or like
I would say that it's very likely it's based on fingers, because before people were very good at math, they probably just counted on their fingers, and that's how they kept track of things. And then, but we do have a base 12 system as well, dozens. How many inches are in a foot? How many eggs are in a carton? How many hours are in a half day? Kind of a dozen situation, right? How many degrees are in a full rotation? Well, 12 goes into 360 as well. So there's a kind of a dozen there. A dozen 30s, a dozen twelfths of a turn, right? We actually think of it in twelfths of a turn. So okay, so this is, so if I were to ask you to do basic multiplication, basic arithmetic, we might say, well, what do these mean? So if I said, well, we've got 13 kids and 13 buses, right? But we can only put, I'm trying to think. I'm trying to think of doing 13 times 13 and thinking of it in terms of sets of 12. Right? If you were to do that, we would not be doing a 10 base, we would be doing a 12 base. And really, we can do any base.
Can I ask a question? Just
Yeah.
okay, so let's say hypothetically, well, let's just say it is base 43 at base 13. So that would be 4 sets of 13 plus would there be four, like then would there be 3 added to that, or 4 sets of
Beautiful.
3? Yeah.
So okay, so we can begin by just it's very tempting to use what we know about base 10 and translate that. But if we were to, let's just actually draw it. Watch. I try not to use base 10, although it's very tempting to do it. So how many 13s? So let's say each of these is 13. When do we get to it was 43, right? When did we get to 43? Well, we would count, well, what is 43? We've already basing it on a base 10 system. I'll go into that in detail in a second. We would stop here. So all of this would not count. So we would have 3 13s and 4 more. That would be the same as, imagine we took the 9 off of the edge here. Now those are 3 10s plus 9 plus 4, which would be 4 10s plus 3.
So you're saying that sorry, let me just ask. So the 3
great questions,
basically,
Scott. Please feel free to ask them.
I'm sorry. So 3 would basically be 0, 1, 2, 3. Sorry, 3 would be it's 3. Would it be 0, 1, 2?
3 would be 0. Oh, you mean base 3?
Oh no, I guess I'm just trying to figure out how to add, how to like does the 3, okay, maybe I'm getting this wrong, but I'm imagining, okay, 43 at base 13, right? It was 4 sets of 13. Then the 3 that's added to that,
It's actually it's actually 3 sets of 13
3 sets of 13.
and 4 more. So if you were to count the squares in here, you would find that there's 43 of squares, assuming that I wrote the right amount of squares. So essentially what we're doing is regrouping. I wouldn't use base 13 just yet. That's kind of a more difficult one because it's a prime number. But if we were to say, okay, 4 sets of 10 and 3 more. And this is not the best example. It was good as an example, just describing 4 and 3, because those are 2 good numbers. But changing this into a different base, we could say, well, how many groups of 6 is it? How many groups of 7 is it? How many groups of 25 is it? And how many more? And we could rewrite these numbers differently.
Oh, so you divide then, do you divide it by the 13?
Well, okay, let's try a different number. If I were to say 21, okay, this is much easier. This is if I were to teach this concept you're asking about, we need to make a more better example. So 21 represents 2 10s and 1 more, right? So what would this be in terms of 12s, Carlos? You'd say, well, how many dozens fit into 21?
In 10s or 12s?
12s.
In 12s, 1 dozen
Huh?
with I'm gonna have to rely on my memory at this point,
That's fine. For now, let's do that.
but I would say with 9 left over.
1 dozen and 9 more. So you might write that. And Jacob or Soleil, in base 5, how many 5s fit into this?
1.
No, no. Did you say what? No, think about like $21. How many
Oh, I
5s?
thought you said in base 5, how many 5s fit into this number? It would be 4 plus 1.
4, 1. Base 5. Ayush, base 8.
Yeah, so it would be 3 and plus, no, it would be 2 and the leftover is 5.
Good job.
5.
So you see, I'm using this subscript. Now let's try another one that gets a little bit more challenging. I think everybody's starting to get this. Jacob, are you there? Jacob better go. Robert, how about base 3? So this is getting a little trickier. So how many 3s fit into this? Actually, yes, but there's a problem though, because we don't have 7 in base 3. Right, so let's actually do 4s instead. So 1 0 0 in base 4 represents 4 4s. You see that? So 1 0 0 in base 4 means 16. 1 10 and 4. So in base 4, how could we represent 21? So we would have this number, which represents 16, plus this number, which represents 4, plus this number, which represents 1. And it would be represented as 1 1 1 with a 4. Let's just make sure everybody gets that, because it's a little tricky. I mean, this is totally new stuff for you guys. But the funny thing is, it's not new at all. This is what you've been doing your whole life. You just were so stuck on base 10 because that's what society taught you. See? So the first one, so if I were to write 1 1 base 4, that's pretty clear. It's 1 4 and 1, right? That's like 5. Right? This first one means 4, and the second one means 1. So that's like 5. And since everybody got this when we did all these, it seems to me like probably that would make sense. But when we're adding the extra 1 in front, it's a set of sets. It means one set of sets added to that. So Carlos, let's talk about it.
It would be 4 sets of 4 sets of 4.
4 sets. That would actually be this one. That's 4 4, right?
Mm-hmm.
So just 4 sets of 4 is this one, because this
So
is
is that 4 times 4 plus 1?
so this one's 4 times 4. This is plus 4, and this is plus 1.
Yeah.
Does that make sense?
Oh,
And 4 times 4 is 16, plus 4 is 20,
So
plus
it'd
1
be
is 21.
16 plus 4 plus 1. Okay, I see it now.
Nice.
That's ego bending right there.
Right? We got to be very humble to explore the fact that if we lived in an alien civilization, we probably would have to go back to elementary school for our math, right? Because we wouldn't even know how to do 21. We wouldn't know how to represent it. But this is the fun of it is you go through it pretty quickly if you practice a little bit. And it helps improve your algebra skills very quickly because this is starting to touch on algebra. But Carlos, do you see how 111 means 144, 14, and one more?
yes.
Nice. So what does 211 mean? 2 4/4s, 14, and one more.
So is that 32 plus 4 plus 1?
Exactly. Right? What about 144? So let's let Carlos do this one.
So it's going to be 16.
Oh, I made a mistake. I can't wait. Did I say so I'm not allowed to use 4. I can't say 144. That's like if somebody said, how much money do you owe me? And they're like 3, 10, and 7. Right? You can't have a digit called 10 in base 10.
Oh, gotcha.
Right? We only go up to 9. And he said, well, what do you mean 3 and then 10? Right? What does that even mean? It doesn't make sense to somebody in base 10. Right? So when I said 144, I was kind of breaking that rule. But what if I said 133? So this is our
Okay.
16.
So 16. And then plus 12.
Yes.
And then 1, right? At the end, it was 1.
Well, the last one's 3. 1,
The
3,
last
3.
one's 3. Okay.
Yeah. So 16 plus 12.
29.
Close, but 16 plus 12 plus 3, not plus 1.
Oh, 32.
So close. So 16 plus 12 is 28, right? Because these make 8.
Right.
And then 3 more, 31. So you're very close. But putting you on the spot and making you do it in your head, we'll practice a little bit a little bit more. Everybody, we gotta work up to it. So what did we just do? 1, 3, 3 in base 4 means a 4x4 for the first one. One of those. 3 4s for the second one. And 3 little blocks left over. And if we were to convert this into groups of 10, you might say, oh, well, here's a group of 10 right there. And there's a group of 10 right there. Right? It's hard to kind of count them and change them into 10s unless you do it very carefully, strategically.
But if they were base 4, you wouldn't even be able to count past 4. So you would group them up in groups of 4 in the way you did there, like the 1, 3, 3.
Right, exactly. Carlos, what were you going to ask?
I think that answered my question. Was you can't go above that, so you can't say 5, for example, if your base is 4.
Exactly. You can't say 5. If you said 5, you say, what do you mean 4? And you mean this is 5 in base 4, right? Because it's 1, 4, and 1. You see how quickly I did that, though, right? I actually gave this some thought for many years. So this is And here's the reason for it. You're probably thinking, well, if you're thinking purely about utility, sometimes this was very useful, actually. But the main reason for this is we want to challenge ourselves to experience mathematics without conditioning. Right? So you see how it was more novel to me when you said 5 and I said, oh, that's 1, 1. I was going through the active doing of mathematics. So how would we represent 9 in base 4? Feel free to blurt it out, somebody.
2,
It'd
1.
be yeah, 2-1.
2, 1, 2, 1.
Nice. How would you say 65 in base 4? I kind of jumped to a harder one, but you can do it. 65 in base 4. Oh, maybe that's too hard. I'll give you a hint. You're going into the next digit place.
Oh, 4 times.
Let me give you a hint. 4 cubed equals 64. And I just asked you what's 65. You might not have known 4 cubed is 64.
So it'd be 301.
3
0, 1.
zeros. Do you mean 3 zeros and a 1?
The number
You meant this.
3. Yeah, like that.
So this would mean 3 16s, which is 48, and 1 more, which is 49.
Sorry, I mixed the cube up with that, but so yeah, just add another 16 there, and
Then you have 4
401.
and then you can't put a 4, right? You have to put a 1 0.
Oh, what the?
Right? I hope you guys sleep well tonight. It's like I had
Oh
this
my
session with
God.
Adam and I realized they can't count anymore.
Oh my God.
So this is it. This is 65 in base 4. But the reason for that is because it's 4 sets of 4 sets of 4, which is 64. That's what this number represents. And 1 more. Nice. Scott, what do you think?
Trying to wrap my head around it. So okay, so 4 sets. Okay, of 4 sets of 4. So it's 16. So it'd be like 16 times. Yeah, I'm just
So
trying
16, so 16
Basically,
times 4 is 64.
Yeah.
okay, yeah. So the number 10 technically represents the number 4 in this sense.
Right. So it becomes difficult. How do you say it? So let's say that 10 means 10 and 1 0 base 4 means 4. So it's better to say here, if I were to count, I'd do this. Let me just count up to 65 and you guys can watch me, right? So maybe it's a little, I'll do it quickly. So 0, 1, 2, 3, 1, 4. 1 4 1, 1 4 2, 1 4 3, 2 4s, 2 4 1. That's 10. That's 9, I mean, right? 2 4 1, 2 4 and 2, 2 4 and 3. But you see, I'm because we don't want to mix the language up. 12 is 12, 10 is 10. We want to try to use the digits. It gets a little confusing because there's no English words for these things, right? So we're trying to find a way to do that. So the next number would be, well, if we have 2 4s and 3, the next number is 3 4s. Then we have 3 4s and Scott?
3 3 1. I guess that would be 3 1.
3 1. And then we have 3 4
Then 3 2.
and
Then
3
3
4s.
3.
And the next number, well, wait a second. What do we do now?
Oh, it wouldn't be 3, 4 because you can't do 4, so that would have to be 3. Okay, hold on. I'm just calculating in my head.
Take your time.
Okay, thank you. Okay, so 34 base 4.
Perhaps you're thinking in the wrong direction though if you're calculating, because what happens after 99 in base 10? What's the
It
next
goes back
number?
to 1. Yeah, it goes back to 1. Or that 100. It's yeah.
Right. So this is like our 99 in base 4.
Okay. So would it be 301?
So the next, what's the smallest 3-digit number we could have?
The smallest.
Well, the first number can't be 0, right?
Mhm.
But these can be. If the first number is 0, it's not a 3-digit number, right? So what's the smallest number other than 0?
1.
It's the same as it is in base 10. The smallest 3-digit number is 100, right? So the next number after this is 100, which represents 1 4x4, and nothing else. Nothing else.
So that's 40 essentially.
Well, it's like, well, it's 40, but it's 4.
But yeah, it's not 40. It's because
Yeah.
that's the wrong language. It's 4 sets of 4.
Exactly.
10 yeah, 4
And 10 sets of 4.
It's
Yeah.
and where 10 actually means 4, so it's really 4 sets of 4. It's funny if you look at it like 100 means 10 tens. You kind of think of this as the front digit. So I want to make 100%, or should I say 16%? That was a joke. Sure that Soleil got it. Yes, that everybody gets this, because so
I was pretty sure I'm the worst person at math in the world, but the one thing, since I never memorized or learned math, all the math I do my whole life is in my head like a picture. So maybe this is why I feel like I'm getting this pretty quick, is because I don't have indoctrination.
Exactly. It's actually can be helpful not to be indoctrinated, which is one of the reasons why we can work with 7-year-olds and 8-year-olds and really help them. If you could have learned this in elementary school, you might say, well, that's too hard for elementary. I don't agree. They had to learn this in base 10. They could have realized that there's different possible bases. I think we should be binumeral. Binumeral means that you should be very familiar with at least 2 base systems, like completely familiar. But I think more like tri-numeral. Like I would say base 12 and base 2 are kind of very important to know both of those. Should be able to say, okay, what's 48 in base 2, right? Just say it, you know? Can I do it? I got it. There, did I get it? Yeah. So that's pretty fast. That's like, can you, what's 48 in base 12? Okay. So what is 48 in base 12? So
20, it's 24. It's 2022 or something like that.
Well, 2022 is a very, very big number in base 12, because this
Oh,
would
I
mean,
thought it was base 2 for some. Never mind.
oh, no, sorry, binary. Remember, in base 2, there are no 2s.
Oh, so
It's
it'd
all
be
1s and 0s, right?
1 0. Oh my God.
Everything would be 0s and 1s, which is called binary. That's what we mean by base 2.
Oh gosh.
But if I say 48, does everybody know that 48 is 4 times 12?
Is it 11010?
Well, Corinne, what are you talking about?
11010.
11010. That's 50.
In a base 2?
Base 2, yeah.
Oh, you did that fast.
Yep. I'm buying, I'm trinumeral, man. Why is this 50? This represents 0. This represents one set. One set of what? One set of 2. This represents, oh my gosh, I messed it up. All right, well, I'll show you how I messed it up in a second. So I did it too fast without totally thinking. So this represents one set of sets, which is 8. Right? And then this one represents a set of sets, which is 16. In base 2, a set of sets means 2 twos, right? So this is 2 times 2 times 2 times 2 is 2 times 2 times 2 times 2 is 16. And if you
So
add,
Would it not be 6 if the third number, the third digit from the right, wouldn't it not be 6? Because if you can only have 1, you can't actually have 2, so the second digit would represent 2. And then to have 2 sets of 2 would be 4 plus that 1 would technically be 6.
the whole thing would be 6?
No, just the first 3 digits there, the 0, 1, 0.
Yeah, so this means 2. So this I wanted to get into the binary. The goal today was talk about binary. I wanted to help you realize that there are different base systems first. So this means 2 in base 2. What about base 12? It means 12. What about base 3? It means 3. What about base 77? It means 77. Because this is one set.
is it 110000?
110000. That's 48.
You were asking about 48 base 2 though, right?
Yeah, good job. You got it. Way to go, Scott.
Wow.
Very good.
Yeah, good
Yeah,
job.
because it carries over. Yeah, I guess just because if you're, yeah, if the limitation is that it has to only be expressed in zeros and ones, you just kind of push it over. I guess the way that I'm perceiving of it is just pushing it over to the left.
Nice. Yeah, you can do things like that where you add a 0 in base 10, it multiplies by 10. In binary, when you add a 0, it multiplies by 2. So if you looked at this,
Oh, it's actually pretty easy looking at it physically in the
Yeah.
picture.
so what is 32 plus 16? 48. So if you put these together,
Yeah.
just these two, we get 110000.
Oh, okay. Before you erase that, I want to write something down real
Sure.
quick. That's such a great way of, okay, visualizing it.
This
Jacob,
made
what do you-
binary super easy to understand.
What was that?
Binary code just became really easy to understand.
Nice. Yeah.
If it was base 2, but it's not, it's base 1, right?
No, it's base 2. Base 1. It looks like base 1. It's base 2 because you either have on or off, 0 or 1. Now, what you focus on, you become. So if you focus on this, you'll start to see the world in binary, ons and offs.
Yeah.
And it's an interesting way to see the world. You start thinking, okay, that street goes that way. That street goes that way. It's either day or night. That's either forward or backwards, right? It's on or off. The sound is on, the sound is off. You can start looking at life in this quantized polarity.
Yeah. And the way with quantum computing, each one of these each one of these rather than on and off, it's a you have like, you want to imagine a sphere, I guess, rotating.
Well, you can have the quantum state, which is both on and off.
Yeah.
which makes quantum computing very powerful. So when Karan said 11010, I actually did this, and then I put the 1 there instead of that 0, which would have made that 50. But I put the 1 in the wrong spot.
Right.
So
one. There's a 1 in at the end, that 110 because that's a 2.
Yeah, so these are both 2. Both of those are 2s.
Yeah.
But these are different. So what was Karan's number then?
Let's see.
So what does this number represent?
So it's 16 plus 8 plus 2.
There you go.
So it's
Jacob, you're muted.
26.
26, nice. So Jacob, I would love to hear from you. What do you think? You ever learn this in school?
Not so much, but I can get behind it. It's a different way to view mathematics than just a human conventional way to teach you.
Well, it's important. It's important to be able to go beyond if you think of it as a practice in how well you can use your mind, how clear your mind is, then it helps you to move beyond memorization. That's the goal. We want to move beyond memorization, and then we're actually developing the faculties. Now, this also can be useful. There's situations where we'd rather use binary than base 10. I mean, computers are a perfect example, but there's other examples. There's examples where we'd rather use various amounts rather than base 10. For example, what is 1729? We've talked about this recently. Well, in base 12, what is 1729? See, and
divide 1729 by 12 would be, that's too big of a number for my brain to put a picture to.
So it's slightly well, I wouldn't say this is memorized, because I see in this, I see this 1,612 tens and 8 more. That's 1728, and we can see that geometrically by looking at a cube, which has got 6 faces, 12 edges, and 8 corners. This is a little bit from a different class, so if you guys weren't there, maybe you'll miss this. But so this is actually 12 cubed. So 1729 is just this in base 12, 1001. So when Ramanujan said 1729 is a special number, it's interesting what he's saying, because if you were to say this in base 12, so Ramanujan said this, he said, 1729 is a special number. It's the smallest number that's a sum of 2 cubes in 2 ways. So it's 10 cubed plus 9 cubed, that's 1729. It's 12 cubed plus 1 cubed, that's 1729. So if we were to say this in base 12, we'd say, okay, 1001, assuming base 12, is the smallest number that's a sum of 2 cubes in 2 different ways. So let's see if I can do this right. It's the same as, well, I mean, I'd be done. The only difference is I'd put a 10 here. And here I would have to use a different symbol, like an A.
Oh, so 1 would be 1, 10 would be 12, 100 would be 144, and 1,000 would be 1728.
Ah, good job. Exactly.
Ah,
So Ramanujan would sound maybe a little less smart, right? Because you'd say 1729, you're like, that seems like a random number. But if you said 1001, you say, well, obviously that's 12 cubed and 1 cubed, right? If I say 1001 in base 10, you might say, well, obviously, Adam, that's 10 cubed and 1 cubed, right? Because it would bring out the fact that 1000 is 10 cubed. All right. So nice class today. a little over again. I hope that made sense to everybody. Carlos, do you feel like it was good?
Yeah, I think like towards the end, I don't know. I don't think I understood too much at the end, but
Okay.
I think everything else made perfect sense. But that's just I think so my question is over time, like with continuous exposure, will my mind start to become more like I guess open and kind of understanding to these kinds of concepts? Because I feel like right now, probably just like exercise, for example, if I try like a new workout or something, it kind of feels I'm having like a similar sensation, just kind of like
It's a nice parallel. You should be experiencing a similar sensation. We're seeking to break down, like when you work out, you break down your muscle so it grows bigger, right? So we're breaking down some of these assumptions that you're making, and I would argue that this will make you better at math because you'll have a degree of confidence. You'll say, "I know numbers," instead of saying, "I don't know numbers, but I'm trying to do things that I don't know what they mean or what with numbers." Now you really know numbers. If you really know numbers, then perhaps you say, oh, 1729 is the same thing as 1001 base 12, right? Like there's a kind of clarity there to be able to make that jump very easily, right? And we're just talking about the basic counting at that point. So but that builds a foundation for, okay, well, can I do integration by parts in calculus intuitively like this? Can I do the power rule in calculus intuitively like this? Can I look at Gaussian curvature? I mean, you probably don't know what I'm talking about because I'm naming off purposely more advanced concepts. That the goal is not to make it rote memorization, but something that we have such integrity of our comprehension in. Then math is a lot easier. It becomes a little bit more second nature to us. If you build that comprehension very, very solid from the foundation. So I would say yes, Carlos, you can.
yeah, I'm not sure if I would call this an abstract way of thinking because because it's just opening up the mind in math, and math is math really abstract? But I would say that because I'm being forced to think in this out of the box way, it's definitely beyond it helping in math. It's going to help with everything you do in life, thinking in out of box way. And even if you tackled music or like you said, a new workout, your brain is going to be working in a more different way now.
Beautiful. Exactly. This isn't just about math. It's about, having a healthy mind, body, spirit. All of them. Like this is just, you can, if this didn't come naturally to you, say what? There's a place I can improve my numbers, my thinking, right? And I think if you haven't done this before, it probably wouldn't come naturally to you. And it's interesting to say, well, wait a second, why aren't we taught this? Why don't we think about this from the beginning? If we're saying 101 in school, why not recognize very clearly that that's 10 sets of 10 and one more? And it could have been 8 sets of 8, but we use 10 conventionally, and you should be binumeral. So I would say every kid should be learning, okay, you like 10 sets of 10 and one more, what's 8 sets of 8 and how many more, right? Like that's another, or 12 sets of 12 and how many more, right? So there's other ways that we can go about If you learn two at once, it prevents you from feeling that the one is the way, because really none of them are the ways. 101 is 101, has nothing to do with grouping it. You see what I mean? 101 is 101. It's a prime number. It has nothing to do with the group sizes. If there were 101 rocks in a pile, it's just a pile of rocks. You add one more, it's a different number, right? You guys see what there's a little profundity in what I'm saying here. Numbers, the only reason we use groupings and numbers is because it's hard to name them. You could have a name for every number up to 1,000,000. You'd have to learn 1,000,000 different words.
Probably the way I would say is describe it in base 10 or describe it in, and that way it's like, okay, you have 101. Now describe it using this thought process.
Groups of 12, describe it in various ways. But it itself is beyond its description, which is beautiful what Scott just added. Yeah, exactly. It's they're the descriptions which aren't the thing. There are ways to allude to the thing.
Yeah, or express it in this particular way, or just express or describe. Yeah. But in the end, the fight, like it is 100. There are 101 units of that thing, no matter what.
Right.
It's just different, yeah. Using yeah, but it is 100. It's expressed. The 101 itself is expressed as 101 in base 10.
Right.
So
1 10 10, 1 10 by 10 and 1.
Yeah,
Right.
110. Yeah, exactly. So that's, yeah. So it's like here. Okay, so here you have 101 rocks. Sorry. Here. Okay. Here you have X amount of rocks that are expressed in base 10 as 101 rocks. How would you express that in base 9?
Exactly.
That's how I would ask that question.
Exactly. If you did in base 9, you would have 199 and 4 9s and 2.
Yeah.
Did you see how quickly I did that? I hope I got it right. 9 times 9 is 81. Wait, 2 9s, 199 and 2 9s and 2. So we have 1 2 2. 81 plus 18 plus 2 gives you 101. So I just regrouped it into 9s. But I actually didn't think of 81 plus 18 plus 2. I saw it visually. I saw a 9 by 9, 2 rows, and 1 in the corner gives us 10 by 10 plus 1 more. So I got an extra 1. That's how I actually saw it. So Robert, last question, because I know we're over. Robert, what do you think? You know, Robert's been a math teacher for many years in school. What do you think of all of this and how it might affect people learning?
I don't know. I guess I was never very good at the base, like different bases and how you broke it down. I like the Pascal triangle looking thing that you showed. That really helped visualize it. And then also you circling back to your, like, oh, I saw a 9 by 9 with the 9 and 9 and 1. Like, wow, that's how you can apply that. And visually, you know, you can, if you really got good at that. I mean, I've tried meditating on it, or just like, you know, hey, I can't sleep. Let me, you know, visualize those 12 times 12. It's super fun. You know, it's just like something to start thinking about. I think it'll really change the way you can view things. And, you know, that's where the genius comes from. Like you're saying, you can awaken it, and you're just going to get these brilliant thoughts because you are thinking totally different than you otherwise would.
Right. Beautiful. I love it. I love it. Yes. In terms of, you know, if you can't sleep or you're just having to raid around at the DMV or whatever it might be, you can sit down and think about these things. Or so you can do 15 minutes a day, or just like review what we did this week. If you spend the next 6 days thinking about this, just maybe count to 15 in binary. 0 1 1 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1 1 0 0 0 1 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0 1 1 1 1. I just counted 15 in binary. Right, so you can practice that. I do that with my students. We always count to 15. I got these little 10-year-olds counting to 15 like that. And they go and show all their friends, and their friends are like, wow, that's cool. So, all right, let me put on the tracks. Tracks are playing. There. Sure. Wonderful. Well, I love our group today. This was fantastic. Tomorrow we have